challenge. Yeah. So the electricity has to reach to each and every person in the country, whether he's staying in village or in rural area. So a lot of effort has to be made by the power sector owners to provide efficient, coordinated, and robust electrical system and operate it economically so that flow of power from generating station to load center and optimal utilization of resources are ensured, and consumer gets a very reliable, affordable, continuous, and quality power supply. That is the overall aim. Now, recently, we have seen the growth of renewable energy sources. I think some people must have talked. Now, there are various factors, but one of the major factors is the environmental concern, which is a global concern. And our pledge to reach net zero goal by 2070 worldwide, they are trying to reach by 2050. But India said that we are a developing country, we'll try to reach by 2070. Now, there are various reasons for renewable growth. One obvious reason everybody says that fossil fuel is reducing, but that is a little a discussion point. We get new site for fossil fuels, but anyhow, it is declining. The concern is that this fossil fuel-based power plant, they emit various type of the polluting gases. Now, dominant being the nitrogen oxide, sulfur oxide, and some ash content, which create local environmental concern. So that has to be tackled. The nitrogen and sulfur content, actually, they mixed with water in the air, create harm to your skin. And the pollution created by the coal-based power plant also creates the breathing problem. So that is the local problem that has to be addressed. But the most dangerous is the carbon oxide emission, which is one of the greenhouse gases. There are many other gases like sulfur hexafluoride, and which are creating this global environmental concern. So they have the greenhouse gas effect. That means that in outer layer of the atmosphere, they get accumulated. And if you have seen in a nursery greenhouse, they allow the sun rays to enter, but not the reflected back at the same rate. As a result, it gives warming effect. So same effect we are seeing, the whole world is seeing the global warming. A lot of the climate change is happening. This year is the worst. I think everybody must have watched how much rains we got. Now, there are many international bodies. IPCC is one of them, Intergovernmental Panel on Climate Change. And then IRENA actually publishes a regular report that is renewable energy related report. Now, IPCC actually predicted that compared to pre-industrial era, that is 1850 or so, if the temperature rise is about 1.5 degrees Celsius, it is going to create havoc in our country. We have already reached up to 1.2 degrees Celsius rise. So the margin left is 0.3. Now, the whole world is concerned, and effect is already being seen. So if you don't take urgent step, this is what going to happen, that more severe conditions will be generated, which is a concern to humanity. Now, other reasons which are listed here is fast declining price of renewables. Thanks to power converter technology developments, very efficient converters we have to interface it to the grid. And ICT infrastructure, the new class of ICT infrastructure has enabled us to go for more automation, more sensor-based operation. So that is the real cause for renewable energy growth. Now, this picture shows that how drastically between 2010 and 2020, the prices of various renewable sources, variable renewable sources have gone down. So the cost of solar photovoltaic, if you compare, it has gone down by 85%. That of concentrated solar power by 68%. Wind also between 48 to 56%. These sources in 2010 were very costly to operate. Now, this black band, if it is visible, shows the levelized cost of energy from the conventional sources. So now they have become competitive, not only competitive, cheaper many times compared to the conventional sources like coal, gas, and so on. So it is going to be very much viable option, and it will help in improving our environment. Now, this is a very interesting publication which IRENA brought out in 21. Yeah, please stop talking. I can mute it. So IRENA brought out in 21, and they have given roadmap how to achieve the overcoming of 1.5 degrees Celsius temperature rise globally. In electrical sector, they said that renewable energy is going to play a major role. So renewable energy share by 2050 in terms of capacity should go to 92%, which includes big hydro. Variable energy, renewable energy, solar, wind, and so on, that should be reached 74% in terms of capacity, and in terms of generation, it should reach to 63 and 90%. So whole world is behind meeting this target, and India has taken very drastic step in enhancing the renewable energy. But before that, little bit history about how the electrical system in India has grown. Our first act came in 1948. At that time, most of the electrical network were owned by the state electricity boards, except few private players like Calcutta Electric Supply, Bombay Suburban, Ahmedabad Electric Supply, and Tata in Bombay. So they were there, and they remain till today. Now, in 75, government thought that let us to operate the central generation facility and central transmission facility, we should form a company which was known as NTPC, and it is still existing. NTPC and NHPC were formed, and they were given the responsibility to generate as well as transmit the power to various states. But to have a more coordinated operation at regional and national level, they separated generation and transmission business in 92-93. And first, from NTPC, they formed another company known as National Power Transmission Company, which was renamed as Power Grid. So that is our central transmission company. In fact, an offshoot of that is Central Transmission Utility, which is an independent company responsible for the planning purpose. Now, power generation was open to private sector in 91, and a lot of changes worldwide actually took place. Deregulation started at that time, and we saw the electricity market. Electricity Regulatory Commission Act came in India in 98, and that established your Central Electricity Regulatory Commission and also the State Regulatory Commission. That is the background. But the real work was done in 2003 by consolidating all the acts and the laws we had in electricity, and Electricity Act 2003 was introduced, which really provided a very liberal framework for power development. Private investment was encouraged. A lot of licensing requirement, which was really very difficult to get, was waived off, except nuclear and hydro. Distribution multiple licenses were allowed. Restructuring of electricity boards, that separation of transmission, distribution, and the generation was actually initiated. The Regulatory Commission, as I told, was formed at every state and at central level. Open access was promoted, that anybody can connect their generator or take power in the transmission network. They will not be denied. And transmission utility were really having the role of wire companies. Competition was introduced. That is the beginning of market in Indian power sector. And traders and market was established through power exchange. Now, if you look the present status, we have centrally owned assets, central companies, and also state level companies. Generation is with central public sector utility like NTPC, NHPC, and so on. Also the state generation companies. They have private players also through IPP route. They are setting up the generation plant in both state and the state and the central level. Now, Central Electricity Authority is actually a planning body of Ministry of Power, which publishes perspective plan, specifically generation. Now transmission has been shifted to the central transmission utility, and electricity plan it revises. Transmission is independent company. As I said, at center, the generation transmission owner is Power Grid, which connects various regions and the states. But a CTU, new company have been formed, that is transmission utility for planning purposes. Similarly, separate transmission company have been formed at every state. Distribution actually is again owned by mostly the government-owned companies, but few private licenses are there. Now, so far as operation is concerned, we have conventional operation through the load dispatch center, Grid India, which was known as POSOCO earlier, is response system operator at the central level, and we have a state load dispatch center. There are 3 power exchange actually operating in our country for various types of market. I'll discuss it in more detail towards the end of my talk. Now, for the sake of better management of electricity, our country was divided into 5 regional sectors: North, East, South, West, and Northeast. Now, they have their load dispatch center, called as regional load dispatch center. So Northern is in Delhi, Western is in Bombay, Southern is Bangalore, Eastern is Kolkata, and Northeast is Shillong. So they are located there. They are regional power companies formed. Now, transmission within the region at higher level and also up to the state is the responsibility of Power Grid. Now, why this was done? Because of the diverse resources we have in different regions. Like Northern, we have runoff river hydro, very weather sensitive load, adverse condition, flood, fog, thunderstorm. I think you must have seen in Jammu Kashmir or the Uttarakhand happening this year. A lot of havocs were there. Northeast has big hydro, mountainous terrain, but difficulty in transmitting the power to the rest of the country. Why? Because this area is known as Chicken Neck area, where Farakka Dam is there. So, and this length is about 23 kilometers. Whole width is 23 kilometers. We have very limited right of way to create transmission asset, which will evacuate power from Northeast to rest of the country. So at one time we were planning 1200 kV AC and 800 kV HVDC. 800 kV HVDC has already come between Northeast. It is multi-terminal. So here, one line goes to northern side, other goes to southern side. Okay. And we already had HVDC link between 2 regions, that is back-to-back and also long distance. So Eastern region is having a lot of coal reserves, a lot of coals are available here. They have pit head based load plants, whereas Western has also very renewable. Western and Southern are both renewable rich state. And this is the area where a lot of wind power plants have been set up in the country. Although we are thinking of the offshore based wind power plants in the 2 regions. So that is why it was divided, and the effort is that inter-regional transmission capacity has to be increased so that the power from one to the other can be shared very effectively. Other effort is that we should operate the whole country as a single grid. And that happened in 2013, December. The whole country became synchronized. Before that, 4 regions, Western, Northern, Eastern, and Northeastern was synchronized. South was not synchronized with the rest of the country. In fact, 2012 blackout, I will touch upon that time. That was the situation. It was called as new grid, 4 of them, and the other was the southern regional grid. Now, little bit situation about present installed capacity. We have touched about 500 gigawatt. Coal share is 45%. Oil and gas is still there. So that share is a little less. But hydro is about 50 gigawatt. Renewables without hydro is 192. But if you include it, we are almost 50% of the total installed capacity in terms of renewable energy. Now, this is the figure of August, which was available at Central Electricity Authority as on yesterday. But September figure is given by Ministry of New and Renewable Energy. So instead of 192, now installed capacity is 197 as of September. Solar, we have already touched 127 gigawatt. Wind, we are doing quite well. I think we are 4th or 5th in the world, about 53 gigawatt. Biomass, locally it has to increase. Use of waste to power also has to increase. Small hydro, wherever possible, has to be added. So country is targeting for 500 gigawatt by 2030. But our losses are very high. Average loss is about 19.27 still. Private ownership is increasing. Per capita, as I said, is 1331. This is a little old figure, but slightly changed. We also have international interconnections between Bangladesh, Bhutan, Myanmar, Nepal, Sri Lanka, and so on. Pakistan we could not make because of the political reasons. So existing capacity of power transfer, and then we are planning to add 6 gigawatt more, which will take us to about 21 gigawatt by end of 2030. That is the international transaction. Now, if you see the share of renewable in various regions, northern, western, and southern is maximum. Southern and western is quite higher, followed by northern, almost 35 to 40%. Whereas northeastern and the eastern has to grow still. We have very good solar potential throughout the country, but wind site is limited. However, the sea-based or the offshore wind has to be added. Interregional capacity has reached more than 120 gigawatt, and it has to be continuously enhanced. We have AC as well as DC lines connecting various regions. Now, transmission, we are doing quite well. We are now one of the topmost country in the world maintaining the quality of transmission of power. So we have already reached to 765 kV in AC is on operation, but 1200 kV line is already there in southern region. It came as test line in Bina, where I was also participated in brainstorming. And then southern one line has come up, renewable rich area to the other area, but because of load, it is being operated at lower voltage. Future, we may plan one lines from northeast to rest of the country, because 1200 can carry 6,000 megawatt, which is same as 800 kV HVDC. So this is the transmission and generation scenario. So renewable growth is quite welcome, but it poses a lot of challenges because of its intermittency and variability. So this is the picture taken from Indian grade. Actually, you see how erratic the changes are there, especially wind continuously changing, solar radiation also changes. Nighttime, it is not there. So you have to meet the demand through some kind of flexible generation. You need flexible generation. It is not easily predictable because it is erratically changing. So various prediction methodology actually have to be very rigorous. Forecasting tool have to be developed. It is very location specific. We are connecting solar and also to some extent wind also by converter interface. Solar specifically is inertia-less, and so it is creating a stability problem. So we will have minute-to-minute generation balance problem, stability problem, voltage and maintaining frequency problem. And protection issues are also coming. Why? Because the renewables are also being added at distribution level, which will cause bidirectional flow. And we have designed our protection system for unidirectional flow in general. So that philosophy has to change. It is already being changed. Now, what will come to our rescue? One is the storage. But grid level, you have to talk about gigawatt capacity or several hundred megawatt capacity. So one viable option which India is going ahead to increase is the pumped storage. Compressed air is being tried out in Europe and Canada, I heard, but this India also has to experiment. So basically it is a tank inside you have to underground, and during off-peak period, you compress the air inside that, and during peak period, it acts as a generator. Compressed air is used to generate the power. Flywheel has very limited application so far. Supercapacitor is good for taking care of transient, but again, because of cost and the size, it cannot go up to grid level. SMES, again, superconducting has its own problem because the nitrogen at very low temperature you have to maintain. So it has not picked up so. Now, fuel cell will come in future in large number because of hydrogen economy we are talking. Now, at distribution level and up to a few hundred kilowatt level, also megawatt level, the electrochemical storage has become very successful. Lead acid, advanced lead acid is already there in the market. Lithium ion also is quite mature, but only problem is that lithium ion the mines are only in China. So every whole world is dependent on China. So we have to go for some other chemistry like sodium-based, zinc-based, and flow batteries for higher capacity. So the lot of work is being done on the storage side. But at grid level, the pump storage, at the sub-transmission and distribution level, the lithium ion and lead acid are being used extensively. Now, because it will create voltage problem also. A lot of solar is there, which doesn't generate reactive power. And during the off-load period, off-peak period, generally the overvoltage have been seen. In fact, one of the blackout recently happened in April this year is the Iberian. Everybody is talking Spain, Portugal. And there, one of the main reason is the lot of renewables they had no voltage control mechanism. So overvoltage was seen. Because of that, the generator stripped and multiple tripping took place. So converters being used for solar, let us say, which is inverter, should not only be used for interfacing purpose. Its other control feature has to be exploited. So one feature we can exploit is that at the sacrifice of slight real power, you can generate reactive power. So it is not a reactive power source, but if you know the principle of STATCOM, it works on that principle. So it is the play of the vector, like 90 degree to the voltage if you inject a current. So that will create reactive power effect. So same effect we can get. So you can have one loop for real and reactive power control. Now this has been made mandatory in India for larger installations. CA has already mandated that. But another problem which we will face is the stability problem where effective inertia will go down. So as a result, your frequency dip will be very high following any kind of disturbance, and it may lead to the instability. So what I think researchers have found out and also being tried out is the concept of virtual synchronous generator, where if you have a small battery or a solar, through controls, you can emulate inertial response through power electronic controls. Or by modifying the control of the converters like PLL control, you can have the stabilizing controls developed. So that will increase the effective, or that will reduce the fluctuation in frequency, or we say that virtual inertia have been added. So this is also can be exploited. Now this has also to be mandated at some point in our country. Now, to evacuate power from the renewable rich area to the load, you need proper planning of the transmission. Now, realizing that, now we have created a green corridor where a lot of transmission lines have been added in our country, looking at the scenario of 2030. And our planning criteria have been revised. In fact, transmission planning was being done by CA. Now CTU is responsible, which is an offshoot of the power grid, for planning purpose. It takes various inputs, like it takes operational input from Grid India, generation plan from the CA, then market scenario, which is emerging. The state transmission utility also gives their feedback, but most important for us is that MNRE also gives the RE growth input for planning purpose. So considering everything, because it can come in a very short time, every 4 to 5 year plan we have to revise. And this is the mechanism which came in 2023, that if cost is less than 100 crore, CTU themselves can approve, and there is a National Committee on Transmission and Ministry of Power, they have to be informed. But if it is between 100 to 500 crore, National Committee on Transmission, they have to approve, ministry to be informed. More than that, ministry has to approve. So that is the process, and once it is approved, it goes for tariff-based competitive bidding or real-time market invitation is there. So that is the transmission plan. Now, every year, transmission plan is revised because dynamically the RES growth is coming up. So Central Transmission Utility prepares this document and they publish, which is, let us say 23, they publish scenario of 27, 28, almost 5 years in advance. So every plan looking at various inputs are actually given in these rolling plans of interstate transmission system. It is not within the state, but interstate transmission system. Within the state utilities are responsible. So, and then a lot of work have been done to meet the target of 500 gigawatt renewable energy capacity. Central Electricity Authority brought out a document in 22, where they said, we gave a figure, estimated figure of this much power to be evacuated, how many circuit kilometer, and what is the MVA capacity of transmission required. This is the approximate transmission cost to be added. We need energy storage of about 51, 52 gigawatt to meet the variability. So all these are being planned one by one. To take care of stability, FACTS controllers and then HVDC lines, they have also been planned. And to manage the renewable energy effectively, renewable energy management centers have also been set up, 9 in state level, 3 at regional level, and 1 at national level. I'll talk a little later. So we are gearing up in advance to take up the challenge of renewables, which we'll have. Now, country has also gone since 2010 the concept of smart grid. So before this concept came, that means renewables were not too many in our network, at least in distribution it was missing. You had unidirectional power flow. Now, once renewables are added at the distribution end, you will have bidirectional power flow. And that is why I said even the protection will have a challenge. Management will be challenging. Various types of renewables will come with the storage, electric vehicle is being added, energy storage is being added at distribution and transmission level. Microgrid concepts are coming up. So, and you need a very strong ICT network. So this red dotted line is the ICT network. Bidirectional communication system is required. Decision support system, and we must have the distribution management system, energy management system at transmission, distribution management system at the distribution level. Now, India, as I said, 2010 itself formed a smart grid task force, and Indian Smart Grid Forum, which is still there. It is a public-private partnership. it is coming up. They bring out different documents, they do brainstorming, organize various forums. Whereas this was government body, they were to at national level how it has to be promoted. Remember, only in 2000 January, the US announced smart grid concept. In fact, I was in US and I was teaching a special course, and my first lecture was on smart grid at that time. So when Barack Obama announced in January 2009 the concept of smart grid, earlier it was called as the intelligent grid. But later on, so they identified various projects. 14 pilot projects were identified on trial basis. As in fact, one came to IIT Kanpur also. We have a R&D pilot where SCADA and everything was demonstrated, meter data management, smart meter, and to some extent renewable integration was demonstrated. But this was replaced by National Smart Grid Mission. In fact, Misra ji, who gave first lecture, was the director of National Smart Grid Mission also. And he was from Power Grid side when this task force was being set up. I was also in one of the task force. So in parallel, at transmission level, Power Grid formed one international committee, 2010, how to promote the use of synchrophasers. So professor from US who gave synchrophaser technology was the chairman, and two of us from India were the members. There were three from outside the country. And that time the blackout took place. I'll just discuss about that. And the boom for synchrophaser also was initiated. Government realized its need. Before blackout, they were not at all listening to us. Now, distribution in past have faced several problems. It was passive, unidirectional power flow was there, consumer was not participating, no attention to consumer. AT&C losses were very high failure rate of transformer. In fact, at one time, I was in a committee to investigate the reason. Transformer failure rate was 6 to 8% in many states. And that was really alarming because they had no equipment health data. They were not maintaining it. And even the maintenance of transformer after failure was very poor. Metering billing was very poor. Quality of supply also suffered. Customer focus was not there. A lot of the supply interruptions we had seen. Now, this smart grid concept tried to address everything, and it also tried to enhance the addition of rooftop as well as the ground-mounted renewables in distribution level, sub-transmission, and transmission level. In fact, out of 100%, 60% will be the rooftop and 40% will be the ground-mounted. That is the plan of the government. So what will change? Distribution also become active with ICT infrastructure, cyber infrastructure in place. They need sensor to sense various data from not only renewables, but also some of the controllers downstream. Need distribution management system to operate through a SCADA system. You need very intelligent relay setting tools, coordinated production tools. So this is being transformed into active distribution network. Now, Government of India actually has had in the past few years, about a decade or so, a lot of measures they have taken. In fact, to start with, Accelerated Power Development Reform Scheme came, where some pilot level they were trying to strengthen the network and also go for the SCADA system, which was again reformed Accelerated Power Development Scheme, but it was subdued into Integrated Power Development Scheme subsequently, where the focus was going ahead with a lot of IT enablement, strengthening of sub-transmission and distribution, metering at every level. So that was the focus. So a lot of effort is being made in improving the distribution infrastructure, which have been traditionally very poor. Now, rural supply was also very poor. So this Deen Dayal Upadhyaya Gram Jyoti Yojana that was introduced, where feeder was separated So like agriculture feeder and the residential feeder was separated. A strengthening of sub-transmission distribution network took place. Metering was introduced. In fact, government brought a policy that microgrid at the off-grid distribution network where transmission cannot reach and rural electrification should be encouraged. But the electricity board, actually, many of them were in red, so they had a deficit. So to bring them at par, revive them, this Ujjal Discom Yojana came 2015, and smart meters were mandated. 35 million smart meters were planned at that time. But the electricity board, they could not come out still. So government have withdrawn that scheme, and they said that now it will be performance-based. If you perform, show improvement in AT&T losses and always cost of supply, then your support will be there. So it is replaced by a revamped distribution sector scheme. So I am showing it. Government is very positively taking various steps. Now, let us talk more on our system operation, our grid operation. So now, for operating the grid, we have one national load dispatch center and 5 regional load dispatch center in one of each region. And every state has a state load dispatch center. Now, national load dispatch center and regional load dispatch center is a kind of which operates their energy management system at regional level and also the interconnected interstate level. So it is owned by Grid Control of India, which was earlier known as POSOCO, Power System Operation Company. Again, this was formed long back, about 2010 or so. Now, about 1 or 2 years back, it became Grid Controller of India, Grid India. Now, their energy management systems are regularly being modernized. Now, how does it operate? State load dispatch center is responsible for optimal scheduling of their state generating units, and regional for the central generating units. Now, to take power from center generating unit, state load dispatch center, day in advance, they send requisition to regional load dispatch center, their respective regional load dispatch center, like UP will send to northern load dispatch center, and then they will allocate depending on the availability of power and also the entitlement of every state. In fact, there was a Gadgil formula known as, so they gave entitlement of every state to the central one. And then accordingly, it will be scheduled. Now, if there is any deviation, one very peculiar arrangement came in 2007-8 that is called as frequency-linked unscheduled interchange. So that time there was no market, no balancing power, but that really helped in maintaining the frequency. I'll just talk a little bit about that. So apart from this kind of power transfer and scheduling within the state, depending on the load they are going to meet, the power supply is also open to market. There are 3 exchanges which are in operation: Indian Energy Exchange, Power Exchange India Limited, and Hindustan Power Exchange Limited. So about 8 to 9% of energy is being traded through these exchanges. And then, as I said, synchrophasor base have come up in a central level as also the state level. So let us see one by one. Now, this is the UI mechanism. So as when the RLDC have declared that how much power next day, every 15-minute block, the state will get, that becomes the base point. And based on that, capacity charge and energy charge is calculated. But actual draw may not be same as what was committed one day before, because the load is quite unpredictable also. So any difference, whether upside or downside, is settled through frequency-linked unscheduled interchange. Okay. Why this 15-minute came? Because at that time, metering was 15-minute block. So energy metering was 15-minute block. Now, how this is fixed? This is dependent on the prevailing frequency of the grid. So if frequency is high, then you will encourage more power to go to the states. But if frequency is low, then you will discourage, you will penalize it. That is the philosophy. So when it started, 2002 it started. So this was the kind of pricing mechanism. So 735, 7 rupees 35 paise was the cost of generation from diesel. That was the basis for this. 49.2, 50.3. Below this, if frequency is, let us say, 48, the charge will be 7.35 if they are drawing more. But if they are drawing less, then they will be paid at this rate itself. So they will be encouraged to, if the frequency is high, then they will be encouraged to draw more. Okay. And in between, the slope was there. So that was decided on certain basis. Okay. Now this underwent several revisions, and this is 2014 curve, where frequency band was narrowed down between 49.7 or so and 50.05. Now further it has been narrowed down to 49.5 and 50.05, as the Misraji also mentioned. So very high rate if you draw more and frequency is low, and almost very low rate if you are drawing more and frequency is high. Okay, both will improve the frequency rate. So that was one. I think this is equivalent to your balancing market in a market scenario. Now, this is the architecture of the energy management system. Like, data is received at remote terminal unit, which is a field unit. So it takes analog data, digital data from CTPT and also the breaker, and then converts into digital form. And through digital communication, it sends to control centers, where they actually run various software, analyze the data, and take various decisions based on the various decision tools they have. Like, they will do state estimation because not every part is metered, or some missing data is there, or corrupted data is there. So they will create a very reliable database. Then load flow, if required, it is run. We have security monitoring programs. We are introducing automatic generation, unit commitment also we do, load forecasting. So these are the energy management system functions. Now every control centers are supposed to do. They are not covering everything, but at least state estimation, load flow, and unit commitment, load forecasting is being done. Others are being encouraged. Now, renewable energy management center have been set up. In these, there are 8 states and 1 in Andaman. Actually, it is called Energy Management Control Center. All these 3 regions are already set up. So it is by the side of conventional energy management system. So they are purely responsible for forecasting and scheduling of RE generations, so that more effective management of RE takes place, real-time tracking of generation and RE resources. So that is the purpose these renewable energy management centers, which is a kind of control desk in the main control center, have been set up. So India is taking all these steps in taking care of various problems, and also at the same time adding large share of renewables. Now, time is not far off when we will have a lot of renewables at the distribution. Market will evolve at distribution. Local market, peer-to-peer trading will evolve. Now, who will manage all these emerging requirements? So a separate system operator will be required at the distribution. Now, realizing that, and also they got encouragement from Mr. Suni, we, as part of one of our Indo-US project, worked on the DSO concept, distribution system operator concept, which has already come up to some extent in Europe, at a beginning stage in US also. So separate distribution system operator will be required, whether it becomes part of the SLDC or part of the area load dispatch center. So 4 different models we have suggested, and we have mapped every state that which model they can select. But coming 5 to 10 years, every state has to go for this kind of entity, distribution system operator. This white paper was brought out, which is acknowledged by Ministry of Power Secretary and also Science and Technology. This is the when this was launched in Jaipur. Actually, that is the picture. Now, system operator will do conventional job of your distribution system management, like network operation, network planning, scheduling, and dispatch, metering, billing. But it will also ensure resource adequacy, effective forecasting of load and DER, market facilitation, ancillary or flexibility implementation. It will give a lot of advantage. Operation maintenance costs will reduce. So you see here the left side, a lot of advantages are listed. It will also encourage a lot of rooftop solar PV addition, which is being talked by Prime Minister through different schemes. And also will ensure that we are moving in right direction to net zero goal by 2070. Synchro phasor, I think many of you may be knowing. It was actually, its use was prompted by various blackouts. In US, when 2003 blackout took place, large deployment of synchro phasor came. It remained in the lab and very few installations were there earlier. Same thing happened when our committee came on trial basis, pilot level basis, 4 or 5 phasor measurement unit, which is the like RTU in SCADA system. In this particular system, we call the phasor measurement unit, PMU, were there in northern, western, and also in the eastern region. But real jump in adding the kind of technology took place after 31st July 2012, where I was also one of the member of the investigation committee. Actually, our committee gave recommendation. Why this is required? Because the SCADA system is not suitable for real-time controls. It gives only magnitude information. So voltage magnitude and current magnitude you will get. But you don't get the phasor information, which becomes critical for stability monitoring, angle monitoring. The wide area monitoring and control is also required. And you need a faster monitoring system. Like SCADA system, its time is about 4 to 10 seconds. The scan rate is 4 to 10 seconds because every RTU it goes and pulls and then comes back. Whereas PMU, which came, the synchro phasor which came, the base unit is PMU, phasor measurement unit, where you take CTPT data and generate current and voltage phasor. And this is directly transmitted to phasor data concentrator at control center, where it is time aligned. In fact, the PMU, you need time data, which comes from GPS. Now, how it works, I think we don't have time to discuss. PMU phasor is a relative concept. Angle is a relative concept. So we take the GPS data and we assume that there is a sinusoidal phasor, sinusoidal signal, which is synchronized to GPS clock. And all the time it is being updated. The reference phasor, which is same at every place in the electrical network, with respect to that, the phase angles are calculated. Okay. And then we run various software. Now, this can give you at this frame rate, phasor, this frame rate. Suppose I go for 50 frame per second. That means every cycle, 20 millisecond, one phasor I'm getting. India has gone for 25. That means every 2 cycle, that means 40 millisecond, we are getting one phasor, which is quite fast enough for the monitoring of the stability. So it is suitable for real-time monitoring, real-time situational awareness. So I'll just show you how it helped in 2012. This was the grid disturbance. I think many of you must be aware that on 30th, this was the pre-outage scenario. Frequency was 49.68. Just recall, the UI rate at 49.68 will be very low. So all these states were encouraged to take more power from the center because they were getting at cheaper price instead of using their own generator. So UP was, and Haryana was drawing a lot of power. So there were overdrawn by northern region. And unfortunately, many lines tripped at that time because of some fault, and also some of them were out for maintenance. The dotted lines were not there. 400 and 765 kV line. Finally, what happened, and last minute some tripping took place. Agra-Bina line, Gwalior-Bina line, that was overloaded. So first day about 1400 megawatt power was flowing in through this, and its SIL is about 600, 700 megawatt. So it was overloaded, but you cannot prevent it because of the low cost through UI route they were drawing. As a result, what happened, the distance relay, because of the overloading, the voltage was low, current was high, so impedance seen by the distance relay became low. But it came in the zone 3 area, so it operated after some time and tripped this line. So 1400 megawatt, which was flowing through this line, was tripped, so it was transferred to HVDC and some of the small AC line, and which got overloaded, and they also tripped. As a result, what happened? The northern got separated from the western, and power was flowing through this route. Instead of western supporting northern, it came via eastern region. So this, and then oscillations were initiated. They were coupled together, and oscillations were seen between northern and rest of the 3 regions. That time, south was not synchronized. So because of oscillations, these tripped one by one. And finally, all the lines were out and northern underwent blackout. A lot of indiscipline were there. The load shedding was bypassed. Governor also was bypassed. So they did not come to rescue. So northern was under blackout. So this was in the late night, and it took almost 14 hours to recover it. We had very few PMU, as I'm mentioning. Northern region, this is the frequency is going down after outage of Pina line. And then here the total collapse of the grid is taking place. So 2 or 3 in Western and 4 or 5 PMUs in Northern region really helped the committee to find out what really has happened. We got the substation data. We took the timings and tried to understand why this jump is there. Each jump indicates some kind of event. So it is there in the report. You can find out why I'm emphasizing that this is a very good technology for situational awareness. If it would have been in large number, then probably situation would have been different. Now, this is the point of separation, I think. So no startup power was there. That is why a lot of time it took play. This is 31st. What happened? They did not understand why it has taken place. They thought that there was momentary fault and the line was reconnected. That time they found over voltage in eastern line, certain part of eastern line. So some of the lines were taken out. So this corridor in eastern line became very weak. Same thing happened. It again got overloaded, but reactive power requirement was high. Although 1000 megawatt was flowing, but MVA was high. That line got tripped. This got separated. But center of oscillation was here because this was the weak transmission network. So Western along with part of Eastern got separated. Rest of the line regions were together, but because of a lot of oscillation, first Northern got separated, then a lot of tripping took place in Eastern, blackout was there in all the 3 regions. Okay. Again, this few PMU data actually help us in correlating the actual event, what has happened. So this is the center of oscillation on that day. So we recommended that large deployment has to be there of such technology because real-time monitoring is important. Apart from looking at the relay setting, more discipline has to be brought. All those governors and the load shedding panels should be operational, should be ensured. So as a result, 1700 PMUs were planned, which is already there at 400 kV and above stations and major generating plants. Many states have gone for PMUs, specifically Maharashtra and Gujarat. Analytics was developed by IIT Bombay, and some of them were from the vendor they have supplied. So it is fully operational. Now, last part, I'm going to talk about the market aspect. I still have time? Hello?
Yes, sir. Yes, sir. Yes, sir.
Okay. So I'll just take 10 minutes more. So the beginning of market was in 2006 and 8, when a very discussion paper was brought out by seers. It was called a staff paper on common platform for electricity trading. So this was the feature which came actually, and it was approved in 2008. That is the beginning of the market in India actually, formal market in India. So they said that we will go for day ahead market first. Like one day in advance, that time it was hourly market. So every hourly block, that is means 24 blocks next day, the generators will announce their capacity and the price they agree to supply, and the utility, like state utility, they will give the load requirement. And then power exchange was set up. So National Power Exchange will settle. So it is a two-way bidding, and they will settle that what price and how much power can be supplied, so that both these parties get benefited. But if somebody is not qualifying, they will not get the power, and they will not supply the power. So double-sided bidding was there. And the price, which was, it is intersection of the generation price and the load price. So wherever demand price, wherever intersection is there, that is called a uniform market clearing price. So it settles that. But then the requirement is sent to the National Load Dispatch Center. They run their program, whether any line is getting congested because of this or not. So if it gets congested, there were several areas in which the country was divided, trading areas. Then price differential will be introduced, that if, let us say, power is going from, let us say, western to northern region, and the line gets congested, overloaded, likely to be overloaded, then price will be increased in the northern region and reduced in the western region, so that you are discouraged to take power in northern region and encouraged to buy power more in western region. So it is called market splitting mechanism was introduced, is still there. Then, so that is the mechanism. So once it is sorted out, so they are given again one chance, and then final market settlement is there, which is informed to NLDC and also RLDC, so that they can supply it, the power in every hour next day, ensure the supply. Now it has been reduced, the time is reduced to 15 minutes. Now participation through this route, purchasing power was not mandatory, it is voluntary. Block bids by generators. Block bid means in 1 hour, they say that at this rate, I'll supply 50 megawatt, and then my price will go up for another 50 megawatt. So block bids were introduced. So either flat or block bids was the option. Transmission capacity was announced to PX that this is the available capacity before they go for the bidding purpose. The power exchange has to pay transmission charges. So there were zonal stamp method earlier. Now it has changed. Lossage actually was added. Loss component was added in the schedule. Like if we anticipate 4% loss in transmission, so 4% will be added to generator to generate, and so that, and then they will recover accordingly. And then there is a financial bank for market clearance and settlement, which was set up. So this was the arrangement. Now, initially, this was the timeline that 11 o'clock power exchange will open for bidding. NLDC informs about capacity at 12. Then 1 o'clock, the bid closes. Then they first round they select and declare the MCP and then send to NLDC. And then NLDC will go ahead signal or will say that you revise it. Then they will revise the schedule looking at the contingency requirement or the system operation requirement. And 5 o'clock, they will give the final schedule. Then Power Exchange will issue buy and sell schedule to participants. Okay, they will publish it. So that was the arrangement. It is day ahead market. Now it is 15-minute block. So, but philosophy is same, but many other market derivative market mechanisms came, like real-time market. Well, it has settled, but last minute, I think load will change. So how to balance that? So for balancing purpose, we have to purchase, like it is kind of ancillary services. Ancillary services, actually, Act has already come up. It is in operation since 23. So real-time market was introduced. Again, 15-minute block, double-sided, but it has a gate closer. Like actual delivery, I think 3.5 hours before the gate closer is there, like in UK, I think. So, or maybe little different. So even for reserve purpose, ancillary services procurement is there for transmission reserve up and down. We also have renewable energy certificate management, like those who are generating green energy, they can get a certificate, one certificate of equivalent to 1 megawatt hour generation. Energy saving certificate, if you can show, then would be equivalent to one certificate if you are saving equivalent to oil of 1 metric ton. Then long-term contracts like term ahead contracts are there, green term ahead contract, and this is to make you more reliable power supply, high price term ahead contract, which can be on the daily basis or maybe monthly or weekly basis, can be exercised. It is kind of bilateral contract. Now we are also talking about derivative market, which is for hedging the price. Okay, so these are the market terminology. I think don't worry about that. I think there may be some lecture on that. Okay, but various form of mechanism have been introduced from time to time. Now these are the recent. I think IEX is one of the power exchange. It has gone for 15-minute. And then 12 bid areas are there. Between two bid areas, bidding takes place. And if congestion is there, the price differential come in the different bid areas. For generation side, it will be reduced. Load side, it will increase. So congestion is through area splitting. So block bids are being provided. Minimum bid size is this much, and this is the minimum price. Minimum price and volume step. So that is already defined. Now, this is the recent one, I think almost recent, I think few years back, IEX shared this. What are the timelines? Slightly changed, like 10 to 12 hours, bids for 15 minutes are obtained, 12 to 1. Market clearing price and volume is calculated and post given to NLDC. Then availability will be assessed by the bank and also the NLDC, and then based on that, final settlement will take place by 3 o'clock and confirmation will be done by 5:30 and scheduling will be sent, requirement will be sent to RLDCs by 6 o'clock. Okay, so that is the recent one. Now, C also publishes market monitoring report every month. This is the latest one. You can see how much volume is cleared through market route and what are the different day ahead market, green day ahead, and then high price, nothing is there. Real time market, term ahead market, and so on. So this is the volume, million unit, and this is the price actually. So HP DAC price was very high. I think that is why the volume is less or almost zero. So a total of about 14,465 million unit in that month out of total generation of 16,1,570. was through the market route. So it is about 9% or so, around 9%. Yes, that is the share of the market. So this has to grow. And so very exciting changes have taken place in our country. So again, as I said, in a very exciting phase we are seeing happening in our country. Smart grid concept came, large renewables are being deployed to address environmental concern. We have joined the international community. Regulatory change in market-based operation is happening regularly. It will percolate to distribution level very soon. Transmission is being expanded and upgraded to take care of the not only efficient optimal operation, but also the requirement of renewables. Now, renewable sources, to evacuate them from renewable reach to load centers and handle the variability, green corridors have been built. Renewable energy control centers are co-located with the regional load, state load dispatch center. DSO is being pursued and it has to come. Now, to improve the quality and also the stability, FACTS controller, large deployment has taken place. Synchrophasor measurement-based wide area monitoring, control, and protection system are in place, and which gives you dynamic visualization and improved control of power system. So thank you very much. That was from my side. If you have any question, please ask that. Should I stop sharing?
Sure, sir, sure. So the presentation is now open for questions. If someone asks to ask some questions, so he's most welcome.
I hope you got some idea about Indian power system.
Yeah, sure, sir, sure. And presentation, some participants are requesting for presentation. Presentation
Please share with everybody.
We have received from sir. Presentation is with us. All the presentations we'll share afterwards with the participants.
Okay. Whenever they want, you can share. No problem.
So if there is no question, there is one small question from my side, sir. What is this market splitting? I think it is related to different prices of electricity at different exchanges.
No, not exchange specific. This is to take care of congestion in the network. So suppose, I think that is one example I gave, from western to northern, if that is one reason. The 12 bid areas, it has been divided. Let us say from western to northern, power is flowing. And after first settlement, MCP has been declared, which is uniform price across the country. So if congestion is envisaged by the NLDC or POSOCO, then they will force the market splitting. Market splitting means the northern side market will have different price, higher price, as compared to western side market. Okay. So that will encourage participants to revise their requirement. Because if you have to pay more in northern, probably you will reduce your load. If you have to pay less in western, probably you will increase the load. So it will try to balance, like it will automatically try to remove the contingency.
Because sometime back there was an order from CERC regarding market unification.
Oh, market unification is different. Like various markets, you operate simultaneously, day ahead and then real time. Everything you operate simultaneously. So as a single market, same settlement is there. Like in, I think in Australia, we don't have day ahead. It is real time market. So that is kind of unified market. So
Canada, Ontario is also
there. Yes. So that kind of unified. Now they are talking about derivative market to hedge the congestion actually. So hedge the volatility in the price because of congestion. So congestion cannot be avoided, but at the bidding stage, they split the market. And then if congestion takes place, again, the generators, they have up regulation and down regulation. Through that they settle. Okay. So I'm sure that Suni must have talked about that.
Yes, sir. It's good. If there are no questions, then I think we can wind up. And what we have
Why there is
learned,
no question? I think you should have a lot of questions.
there may be, but actually, it will take a time to digest.
Okay. What I suggest that they can send through email to you. You compile every question. I will answer that later on also.
Sure, sir. Sure.
Okay, I'm open to that.
So today, what we have learned, how much effort needs to be done at the back end to manage our power systems. What we people don't know, actually, what we most of the people are teaching electrical engineering courses, but we don't know what is going at the back end. So then only this system can be managed. And with this presentation, we come to know about that. We also learned what are the new issues where the research is required. And with these words, I would like to once again
before you say that, I would just tell all the participants, although you might be working in power area. Now, the power system today is not only that generators, transmission line, and the distribution conventional system. Now, because of intelligence required, you need the knowledge of sensors, communication. Once communication comes, communication-based control comes, cyber security concept. So you name any discipline that will be required. So my suggestion is that while you are doing research, do multidisciplinary research. Collaborate with other faculty members, maybe computer science or communication engineering, so that you also learn and they also get a platform for the use of their concepts. So both will be benefited. So the time has come that don't work in isolation. Try to work in the group and take the advantage of various disciplines available in your institute. Okay, best of luck. So thank you very much for that.
Thank you, sir. Thank you. So I'm concluding the meeting today. Thank you, sir. Thank you.
Thank you.